And welcome back. We are now in section 12.3. Chapter 11 is behind you. That was a tough chapter. You're going to be okay. Chapter 12 is not nearly as long. It's only like 5 sections, and it's over stuff you're familiar with. Like, for example, section 12.3, measures of central tendency. When you hear the word central in statistics, I want you thinking about averages. It's where the majority of the data is, in the center. Not way high, not way low, in the center. So measures of central tendency. We are going to study 4 of them, all right? Mean, median, mode, mid-range. They all start with M, and they are 4 of the measures of central tendency, ways to describe the average, and they all act a little bit different, okay? The one you're most familiar with is the mean. When you think of the word mean, think of it's the mathematical average. It involves the most math. And for some of you, you think math is mean. So it'll help you remember it. So mean is mathematical. A couple of symbols for you. If you ever do anything with Excel, you might recognize this sigma symbol. It means to sum. Sigma means to sum. Okay, we use a lot of the Greek letters in mathematics because they look so cool. So sigma means to sum. In statistics, you're typically going to be summing x values, okay? And x values are data values. Always, when you see x, it's representing a data value, okay? So the mean, well, how do you find the mean of, say, your test scores? Well, you add up all your test scores, all the x values, and you divide by what? The number of tests you've taken. That is n. In statistics, n is always the number of IQs, number of whatever, shoe sizes, number of test scores, okay? So this is a cool little formula for the mean. It's the sigma of all the x's, summing up all the data values and dividing by n. That will give you the mean. Now, if you want to do it in one step, I strongly encourage you using parentheses in the top. Otherwise, just add up the top, write the number down, and then divide it by n, and you'll be fine. But just be careful without the parentheses. If you do it all at once, you might confuse your calculator. All right, let's show you how this works. And this book has some strange examples. Example number 1. In 2003, there were 12 inmates on death row who were proven innocent and freed. I guess that's great. In the 5 years after that, there were 6, 2, 1, 3, and 4. Find the mean number of death row inmates proven innocent for the 6 years. Okay, so when they're talking about the 6 years, they're also talking, don't forget about 2003. Okay, so let's simply add up all those numbers. So we had 12 the first year, plus 6, plus 2, plus 1, plus 3, plus 4. Okay, and if you don't have your calculator, go get it right now. Pause the video and go get your calculator. You're going to need it. Okay, so I'll wait. All right, you're back, and you're back with your calculator. So 1, 2, 3, 4, 5, 6. Those are the 6 years, and we're going to divide by 6. So add up 12 plus 6 plus 2 plus 1 plus 3 plus 4, and we get 28. Divided by 6, and we get about 4.7. Okay, I know it doesn't really make a lot of sense, but a lot of times statistics, you get numbers that aren't exact. They don't fit the data well. Like, what is it? The average family has 2.5 kids. Well, that doesn't make any sense, but that's the average. Somewhere between 2 and 3, right? So this is almost 5, closer to 5, but in between 4 and 5. Okay? All right. The median. When you see median, I want you to think middle. So mean is the mathematical average. Median hardly has any math. It's the middle. But again, it makes sense. These are called measures of central tendency, and averages tend to be around the middle of a data set where most of the people, light bulbs, shoe sizes, whatever is hanging out, okay? Salaries. And in this case, it's reported that the median salary for all federal government employees as of 2009 was about $60,680. That's an average, okay? You'll notice that the median is reported more than you realize. Anything involving salaries and incomes and home values, always medians. You'll find out why in a minute, but always medians, not means. So this is saying that half the government employees made less than $60,680 and half made more. Median, right in the middle. Okay? Easy way to find the median is it's the halfway point. After you've arranged the data, don't forget to arrange the data from smallest to largest. Okay? And then look for the middle item, the middle data point. All right? All right. Let's take a look at an example. Well, not yet. So arrange the data in order from smallest to largest, and then you have two possibilities. You might have an odd number of data items. In that case, you'll have an actual median. The actual median will be one of your data items. If, however, you have an even number of data items, then you'll have to average the two middle items. Okay? I'll show you both. So here we go. Finding the median of a data set involving test scores. Okay? So, I want mean and the median. Okay, so let's do the mean first. How do you find the mean? You add up the data items. Yep. So add up the x's and divide by how many. So have your calculators ready. So 84 plus 90 plus 98 plus 95 plus 88. 2, 4, 5 tests. All right, here we go. 84 plus 90 plus 90. Pretty good test scores, huh? 95 plus 88. 455. Divided by 5. 91. 91 is the mean. Okay? All right. Let's go and find the median. Now for the median, what do we do first? Always arrange the data items. Boy, don't forget that. 84, 88, 90, 95, and 98. Whoops, goodness gracious. Sorry about that. Okay, so there's our data, and now all we're going to do is look for the middle item. Now what I encourage you to do is cross out the numbers on the outsides, work your way to the middle. This one's pretty easy, you can see it, but this is just a good habit. So cross one out, cross one out, cross one out, cross one out, and there is our median. Okay, and they're actually pretty close, aren't they? The mean was 91 and the median was 90. Pretty close. All right, now this is very, very, very interesting. Check this out. So let's say you took one more test and you got a 45. Ouch. You guys have been doing this student thing long enough. You know that is going to hurt, right? Well, let's see what it does. So let's recalculate the mean and the median. We'll do them both, and we're going to see what this 45 did to our average. All right, so the new mean, remember the mean involves adding up all the scores. Well, we don't need to add the other 5. We just did that a second ago, right? It was 455. Okay, so 455, 455, but now we're going to add the 45. We're going to add the 45. And instead of having 5 tests, right, we now have 6 test scores. Okay, so let's see what happens. So 455 plus 45, hit equals, and then divide by 6, and then divide by 6. 83.3. Ouch. or basically 83. Wow, what did you have? A 91, and that one test score brought you down to an 83. Well, you knew that was going to happen, right? You've been at this a long time. Let's check out the median. Let's see how the median responds to this, okay? So order the test scores once again. Now the 45 is at the bottom. And now the rest of them. 84, 88, 90, 95, 98. Okay, and now we want to find the middle. Best way to find the middle, again, especially the more data you have, the better I recommend this, but right now we'll just cross out the ones on the outsides and work our way to the middle. So cross it out, and look what we've got. We've got two numbers in the middle. Well, this is the other situation. Back here we had an odd number, 1, 2, 3, 4, 5. We had 5 items, and we had a true middle. Now we have 6, so we have to find the average of the middle. So just average it out. 88 plus 90. Hopefully you can see what's in between 88 and 90. 89, right? But good practice. 88 plus 90, hit equals, divided by 2, and you get 89. Well, that's interesting. That's interesting. Look at what happened here, gang. What was your median the last time? The median in the last example was 90, and the mean was 91. Well, you went from 91 down to 83, and you had a 90 before, and you only went down to 89. Why is that? And you're thinking, man, why haven't my professors been using the median to calculate my grade? Well, some aren't even aware of this, but it is a little bit more tricky, and not all the software allows us to do that. But a weighted percentage does help minimize the damage of a bad test score. But let's look what happened so you are informed and you know what happened here. Mathematically, the 45, okay, was way below the 91, right? I mean, it's less than half of what you normally got. So numerically, as far as a number goes, it was way below. The median is really more of a positional average. That's why we arrange them all. So look at this. Look at the way we did this. This 45, it could have been any number, right? It could have been an 83 or an 82 or a 0 or a 5, and it wouldn't have changed the answer. It's just sitting here taking up one spot. Okay? The median is much better at hiding what we call an outlier. And that's why it's used to report things like incomes and home values. You don't want, the big fancy house on the end of the street affecting your taxes, okay? Just like you don't want the poorly kept rundown house influencing your value when you go to sell. So that's why we use medians. So eventually, if you kept getting bad grades, the median would get shifted down. But with only one bad grade, it can handle it. That's pretty cool. I think that's pretty cool. Hopefully you kind of learned something about the difference between the median and the mean. Okay? Well, go ahead, and I'm going to stop this now because I've already gone a little bit long. And then video 2 will pick it up at the mode. Okay? So I'll see you in a minute. Bye.